Alright, Module 5, Lesson 3. This is the last lesson for Module 5. We are going to talk about the normal distribution and z-scores, and we will be looking at problem solving with the normal distribution and z-scores. So the definition for normal distribution is a bell-shaped curve symmetrical about a vertical line through its center, and it is used to make predictions about an entire population using data from a sample. So this is what the normal distribution or the bell-shaped curve looks like, and it is said that all of the data from a data set or like a set of data fits in this bell-shaped curve somewhere. So everything under this line is going to be 100% of that data set, and it's broken up by each section. We've got 0.15% on the ends, 2.35%, 13.5, and then 34 on both of the sides. So the way that this works, it says that we have the 68, 95, and 99.7 rule. So it says that approximately 68% of the data items fall within one standard deviation of the mean. So we learned how to calculate standard deviation in the last lesson. What this is saying is that 68% of the data falls within one standard deviation of the mean. So that would be these two pieces right here. They make up 68%. On number 2, it says approximately 95% of the data items fall within two standard deviations. So this section and this section all make up 95% of our data items, and then 99.7 of the items will fall within 3 standard deviations. So the way that you fill out this curve is by either going 1 standard deviation up, 2 standard deviations up, or 3, and then same going backwards, -1, -2, -3. So we'll look at some examples. I know it's kind of confusing just looking at it, but we'll look at some examples on how to set this up. And then we will also talk about z-scores, which is how many standard deviations a particular data item lies above or below the mean. So not all the time is it going to be exactly 1 or 2 standard deviations. Sometimes it could fall in between. So we'll use the z-score formula to figure out that. And the z-score formula is by taking our data item, subtracting our mean or the average, and then dividing by the standard deviation. So on all of these exercises, you will be given the mean and the standard deviation. So you won't have to be calculating any of that. And then we'll be converting back and forth from the z-score to the data item and then working with this bell-shaped curve. All right, on exercise 1, it says the scores on a test are normally distributed with a mean of 100 and a standard deviation of 20. So we are going to fill out our bell-shaped curve. One thing that always stays the same is our percentages. So you are allowed to use this on the test. Each of these percentages are always going to stay the same. So you can start out with 34% in the middle, and then the next two pieces are 13.5. So we have 13.5 on each of these sides. And then this piece would be 2.35 And then don't forget we have the very little piece over here, which is 0.15%. And it says we have a mean of 100 and a standard deviation of 20. So our mean is always going to be in the middle. That very middle line is going to be the mean. Here we have the mean of 100. And then the standard deviation is 20. So up here it has just the numbers 0, 1, 2, 3, and then -1, -2, -3. That means that this line right here is one standard deviation above the mean. So in this particular question, our standard deviation is 20. So we would add 20 one time, and we get 120 is going to be this line right here. If we add 20 two times, then we get 140. That is going to be this line right here. And then if we add 23 times, that would give us 160, which would be this line right here. So one standard deviation, two standard deviations, and then three standard deviations. And since we added on this side, we are going to subtract on this side. So 100 minus 20 is 80. We'll subtract 20 again, which would give us 60, and then subtract 20 again would give us 40. So this is how you're going to set up these bell-shaped curves. It says on A, we want to find 2 standard deviations above the mean. So we've already kind of filled out our graph. 2 standard deviations above the mean. We can find this by adding it up. So 1, 2 would be this right here. So it would be 140. We can find the answer by getting it from our graph, or you can actually add 100 plus the 2 standard deviations, and we would have to multiply 20 times 2. So that would be 100 plus 40 is 140. All right, on B, it's asking for 2.5 standard deviations below the mean. So we have above and below. Above is going to be to the right, and below is to the left. So 1, 2.5 would be right in between 60 and 40, which would be 50. So you can use the graph, or you can do 100, and since we want to go below, we're going to subtract, and then it would be 2.5 times 20, which would give you 50. On number 2, it says using the 68, 95, and 99.7 rule, we are going to find the percentage of buyers who paid. Okay, so what this rule is just basically these percentages. We're going to keep these same percentages that we've been working with. So like I said earlier, these percentages never change. So it's easy for you to just turn your page, but for me, I'm actually going to redo this. Okay, I'm just going to... So it says that our mean is 17,000. I'm just going to put 17K. And then we have a 1, 2, 3 standard deviations above, and then 1, 2, 3 standard deviations below. So our standard deviation is 500, so that means we're going to add 500 to our right side and then subtract on the left. So plus 500 would be 17.5K. Adding 500 again would give us 18K. And then again we would have 18.5 thousand. And then subtracting 500, we would have 16.5 thousand. Subtract 500 again, and we've got just 16,000. And then one more time, we have 15.5 thousand. So we have filled out all of our standard deviations. Now we want to find the percentage of the buyers between all of these. So I'm going to fill out our percentages. Remember, these pieces never change. We have 34% right in the middle, 13.5%. We've got 2.35, and then last is the 0.15%. So on A, it's asking for the percentage of buyers between 16.5 and 17.5. So we've got 16.5 and 17.5. We have 34 and 34, which is 68%. On B, we want the percentage of buyers between 17,000 and 18,000. So we've got 17,000 here and 18,000 here. We are going to add 34 and 13.5. Gives us 47.5%. Let me write this out. 34 plus 34 equals 68. On C, we have between 15.5 and 17,000. So 15.5 is right here, and then 17,000, we are going to add 2.35% plus 13.5% plus 34%. So we can add all of these together and you should come up with 49.85%. And that makes sense because half of our graph, if our entire bell-shaped curve is 100%, then half of it is 50% of our data items. And if we were looking at all of the pieces except for 0.15, then we would subtract 50 minus the 0.15. On D, we want more than 18,000. So 18,000 is right here, and we want everything to the right, which would be 2.35%, and then 0.15%, which is 2.5%. And then the last one is less than 16.5. So 16.5 is right here, and we want everything that is less than that. So we have 3 sections. We've got 0.15, 2.35, and 13.5. So 0.15 plus 2.35 plus 13.5, you should get 16%. All right. The next exercise, we are converting the data items to a z-score. So the data items can be pretty much anything. Most of the things that we're going to be looking at is like the real life situations would be stuff that you see in like the healthcare or like in medical facilities, like cholesterol levels and blood pressure and stuff like that. So this one, they don't really tell us what we're looking at. They just say that we have a set of data items and it's normally distributed. So that means that everything falls in that bell-shaped curve. They tell us that our mean is 60 and the standard deviation is 8. Convert each item to a z-score. So our z-score formula, I'm going to rewrite it right here. We take our data item minus the mean and then divide by our standard deviation. So these items right here that they give us are going to be our data items. So z equals 84 minus our mean of 60 divided by 8. And you should get 3. On B, we have 52, so 52 minus 60. So the only thing that is changing is our data item. And then all that divided by 8, and you should get -1. And then the last one is 40. So 40 minus 60 divided by 8. And we get -2.5. And remember, our z-score tells us how many exact standard deviations we are away from the mean. On number 4, we're going to be working backwards. So they give us the z-score and then we have to convert to a data item. So it's given what the z-score formula is. If we were to manipulate this and get the data item by itself, we can change our formula. So if I was to multiply the standard deviation, we would get that z times the standard deviation, and then we would add our mean, gives us what our data item is. So our z-score times the standard deviation and then add our mean. So our data item, I'm just going to say x equals, we take our z-score, which in this case is 3, multiply it by the standard deviation of 50, and then add our mean of 400, and we get that x equals 550. Okay. B, we have that z equals 1.5. So the only thing that is changing in these is our z. The mean and the standard deviation are staying the same. So 1.5 times 50 and then add 400, we should get 475. And then on C, z equals -2. So we have -2 times 50, and then we add 400. We should get that our item is 300. All right, the last part of this lesson 3, we are going to be doing some problem solving, so some real life situations dealing with z-scores and the normal distribution. So they do give us a table, and they have a z-score, and then they have the percentile that corresponds with that z-score. So you are allowed to use this on the test, and I do believe most of the questions that use this, they give you this table on that question. So number 1 says to find the percentage of data items in a normal distribution that lie below and above the given z-score. So the way that works is that, remember, our z-score is how many exact standard deviations we are away from the mean. So in this case, we had like 2 standard deviations above and 2.5 standard deviations below. So these would be our z-scores. So where this z-score is, let's say that we're looking at A, where our z-score was 140. Everything that is below is going to be that percentile, the percent to the left. So that is going to be what's below that z-score, and then everything to the right is what is above that z-score. So we're still looking at our normal distribution bell-shaped curve. And we can also use our table. We don't have to use our curve necessarily. So it tells us that on A, z equals 0.6. So we're going to go to our table, and we are going to find where the z-score equals 0.6. So 0.6 is going to be right here. Everything that is on our table is what lies below that z-score. So this would be our answer for part A. So part A would be 72.57%. So below equals 72.57%. So everything that is to the left of that z-score would be this percent. That's what is given on the table. To find what lies above our z-score, we have to subtract 100 minus that 72.57. And we should get 27.43%. Okay? So again, everything that is listed on the table is what lies below the z-score. So let me write everything on table lies below the z-score. Okay, on B we have that z equals negative 1.2. So we're going to go to negative 1.2, and we get that our percent is 11.51%. So that would be what lies below 11.51%. And then for above, we would subtract 100 minus 11.51%, and we get 88.49%. Let me box these answers in. All right. 2, they give us 2 different z-scores, and we need to find the percentage of data items that lie between those 2 z-scores. So on A, we get 0.2 and 1.4. So let me erase this. We've got 0.2 and 1.4, and we need to find the percent that lies between. So whenever we need to find what is between, we have to subtract. So we've got one z-score right here that is 57.93, and the other one is over here somewhere at 91.92. In order to find the percent that lies between, we need to subtract 91.92 minus 57.93. So for 91.92 minus 57.93, we should get that the percent between is 33.99%. Okay. On B, we've got -2 and then -0.5. So -2 is right here, and then -0.5 is right here. So we would have to subtract these two values, these two percentiles, to find what lies between. So 30.85 minus 2.28 should give us 28.57%. Oops. All right. Number 3, we have blood pressure readings that are normally distributed. We have a mean of 121 and a standard deviation of 15. We're going to use our table to find the percentage of people with blood pressure readings, and then they give us 3 different scenarios. For the first one, we want below 142. So 142 is our data item. So we have to first convert this to a z-score. So remember our z-score, we take the data item minus the mean and then divide by the standard deviation. So 142 minus our mean of 121 and then divided by the standard deviation of 15 should give us a z-score of 1.4. We now need to go to our table and find 1.4, positive 1.4, and that is 91.92%. And remember, this is below. So below equals 91.92%. Okay. So that one was easy because it was below. The next one is above, so we'll have to subtract from 100 to find what it is above. So 130 is our data item, so first we have to convert to a z-score. So we take 130 minus 121 divided by 15, and we should get a z-score of 0.6. And we're going to go to our table. 0.6 is right here, which is 72.57. Okay, so below equals 72.57%. Above equals 100 minus that 72.57, which is 27.43%. And then the next one, we want between 112 and 130. So 130 is up here. We already found that one. So really we just need to convert 112. So we've got 112 minus 121 divided by 15 gives us a z-score of negative 0.6. So we're looking at negative 0.6 and positive 0.6. And remember that below was 72.57%. So if we look at negative 0.6, that is 27.43, huh? So this one is 0.43%. So whenever we want to find what is between, we have to subtract 72.57 minus 27.43, and we should get 45.14%. All right, the last one that we're going to look at, we have a table and it says the age of U.S. drivers, and then they give us all these ages and then the percentile that corresponds with that age. So the way that this works is that we have on the first row, we have the age of 75. That's basically everybody who is 75 and below. So that means we have ages 16 to 75, which makes up 98% of the drivers. Same thing for the next row. For 65, we have ages 16 to 75. So that's 65 and below. That makes up 88%. So all the way down, that's how this table works. So it says use the information given by the table to find the percentage of drivers who are A, younger than 55. So we're going to go to 55, and remember the way that this works is this is 55 and below, so 16 to 55. So that means we would use this percent for this answer, 77%. Okay, we want at least 25. So if you're at least 25, that means that you are 25 and up. Okay, so the percent of drivers who are 25 and below, so 16 to 25, is 14%. So the 14% would be below. To find 25 and up, so above, we would have to subtract 100 minus that 14%, and we get 86%. And then on the last one, we want at least 20 and then younger than 65. So at least 20 would be here, but this is 20 and below. So that is 5%. And then we want younger than 65, so that is 88%. So we want to subtract these two percentiles. 88 minus 5 gives us 83%.